Good morning, everyone. Good morning, sir. I am Giancarlo Balaba, and this is our PIT for the subject na EBA. Akong kauban sila John Scott and Mark Anthony Tesala. And here, i-report na mo ang amo ang data kung yun sa pagbuhatan. Step 1, generating mock data. To start, we needed mock data to simulate the structural failure risk. We used Mockaroo, an online tool, to generate this data. We created a dataset with 200 rows representing 200 observations over a 2-year period. Here is a breakdown of the columns in our data set. We do have environmental conditions, traffic load, material fatigue, and date. And mauna mo ang gibat sa step 1, sir. We did generate sa Makaru, nagpa-help me sa Makaru, and generate na mo ang environmental condition, traffic load, material fatigue, and date. And mauna ang nigawas sa Excel. After na mapag-generate, natagaan niyo og kani environmental, traffic load, and material fatigue na yung mga values there, sir. Random siya dihatag sa gikan Makaru na mga value, and we also do have the date. Ang kanay nasa ano, these are the examples of 15 na rows pa lang, sir, sa amo ang sa among data. And step 2, defining high risk and low risk data. To simplify our analysis, we established thresholds for what we considered high-risk scenarios. These thresholds are essentially to identify when the likelihood of failure becomes critical. The criteria for high risk are as follows. So, pag ma-high risk siya if the material fatigues are greater than 0.8, if the traffic load is exceeding 50,000, and environmental condition temperature is above 65, makonsider siya na high risk. And here, sa among data again, sa among Excel with the help of ChatGPT sa mga formulas, na-conclude na mo sir na dani sa environmental since higher siya og 65, since higher siya og 65, so nahimo siyang high ang kanidare. And here naman sa traffic load, since wala siya ni-exceed of 50,000, na-conclude na mo na these are all lows, kani and kani. And here's some material fatigue. Na-conclude po na mo sir na some are high, kanang nag-exceed of 0.8, and there are also low na wala siya ni-exceed of 0.8. And here's a step 3, calculating the overall failure probability. To calculate the overall probability of failure, we first determine the individual probabilities for each factor. For the P-temp, for the P-traffic, P-fatigue. Next is we use the union of probabilities formula to calculate the combined failure probability. This formula helps calculate the probability that at least one of the failure conditions will occur. By accounting for overlaps between conditions where multiple risks occur, we get a more accurate estimate of failure risk. And here's the step three, sir. Ano na mo, ikuha na mo ang probability or atong mga highs and lows for P-temp, P-traffic, and P-fatigue. 1, sir, represents high and 0 represents low. And mo na mo ang gibat. And here's the date. We do have 1, naka 1 siya talaga. And for the success rate probability, nakuha na mo siya by adding these three, kanang P-temp, P-traffic, P-fatigue. I-add na mo siya, and the sum is amo siyang i-divide into 3 because there are three trials here. And mao ni we concluded kani ang mao ni ang among na-conclude using the formula kani sir, and kani po overall probability, and with using of overall failure probability na formula, nakuha po namo ang overall failure probability which are all 1 kani sir. And nakuha po namo ang number of failures sa dahil sir kung pila ang na-fail sa out of the tulo ka trial, just like for example kanina adari sa temp, we do have 1 and 101, which means na ay isa ka 0, which means na ay isa ka failure, and we do have 2 ones and na ni two number of successes, and nagpalalim na siya sir.
Sir, I am Johnny Engineer from BC Tudo.
And we are the group 7. And I will be explaining to you the step 4 binomial probability calculations. Next, we apply the binomial distribution to predict how failures might occur over time. The binomial formula is used for estimating numbers of failures over specific times or periods, such as per month. The formula used is P x equals K binomial N carry times P over K times 1 minus P over Nk, where P is the overall probability of failures per month and N is the number of months. K is the number of failures in those months. To make this clearer, we created a table that shows the relationship between overall probability per month, the numbers of months, and the numbers of failures. For instance, for n equals 1, we calculated the probability of exactly one failure. For n equals 2, we calculated the probability of 0, 1, or 2 failures, and so on. This gives us insights into how many failures we can expect over time based on the conditions with simulation. And this is our table. As you can see, our total trials are 3 on each trial, and the success trials are 2 and 1. To get the success rate probability, as Ian said earlier, we need to add these 3 trials and divide it into 3. So this will be the answer. And for the binomial probability, we're going to use this formula to get this answer. As, as I stated earlier, P is equal to the overall probability of failure per month, P is the number of months, K is the number of failures in those months. So we will plug the values of this into this formula so we can get this answer. And so in conclusion, this analysis provides us with a framework of estimating the failure probability of a structural components under various conditions. By using both the union of probabilities and the binomial distribution, we can predict how likely failures are to occur, and the plan maintenance or the next strategies accordingly. Thank you.